So f of x one more time.
Yeah, it's g of x equals log parentheses x minus 3 close parentheses.
Very good. So in this problem, we are asked to find the domain, and it's very similar to the square root.
Well, they're asking to graph the function and then the acidic.
Right. So no matter what, we have to start with the domain. So x greater than 3. So the domain of this function is 3 to infinity. And now if you graph using transformations, this is what I would do. We must refresh our memory or remember that this is the graph of the log. Log base 10, I shouldn't write it because we don't. Log, common log of x. We graphed this function last time, so please remember the graph, log x. Now, the base function is log, common log, oops, I didn't mean that, common log x. And then, what transformation is this? Exactly, which means that this vertical asymptote moves 1, 2, 3. So now the new function has x equals 3, a vertical asymptote, and this point must move 3 to the right. This point is at 1, 0. Where will it move? Exactly. So this is the graph. This, the red graph, is log x minus 3.
I guess where I'm maybe.
Yes.
It was. Yes, this is very kind of simple. So, but so whenever it's log x,
Yes.
that point always means 1, 0.
Yes.
And then you just move it from
yes. Let me go back and you'll see why in a minute.
Because that's where I was confused about. I was just
yes. Yes. So remember, the exponential and the log are inverses of each other.
Yeah.
So when we graphed 2 to the x, we got when x is 0, y is 1. What point will that be for the inverse function if the function has 0, 1?
1, 0. Okay.
So that's why we get this.
I guess I missed that. Okay, that makes sense. That's
because the original function, which is e to the x, had 0, 1. Therefore, the inverse function must have 1, 0. Otherwise, they will not be inverses of each other. It's good to discuss these things because otherwise we will not remember them. So that's why it's always the best thing to do is to redo what we did last time, and then ask questions about it. Because that's when discussing. If I tell you, oh, blah, 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 and we don't discuss about it, then we will not retain it.
Yeah. So if it's in the exponential form, it's just
yes.
reversed.
So this is the exponential function crossing at 1, and if you remember, right? So that these two are inverses of each other. They are symmetric with respect to y equals x.
All right, thank you.
Sure, my pleasure. Any questions here? Any questions?
I don't understand.
Which one?
I just don't understand.
Which part?
Any of what you taught.
Did you redo the problems we did
I don't
last?
understand any of what you taught last week, so I didn't redo anything because I just don't understand. So I'll just go get some help or whatever. So right now I'm super lost. I'm gonna be lost all class, so don't really have to worry about it.
I'll be more than happy to spend time with you after class if you want.
Right,
Okay. Any questions? Any questions here? Any questions? You sent me another problem. Was this the one?
There was similar. I can figure it out. I missed that. I just missed that 1, 0.
Okay.
I guess okay.
Okay, perfect.
Thank you.
My pleasure. So let's go back then to, we looked at applications, we graphed. Okay, our next step would be properties of logs. So I pulled out the syllabus here just to make sure that we understand how much more we have to look at. So one more time. So we have to finish chapter 4. We have these 3 sections to finish. Then we have 3 sections from chapter 5, 1 from 6 and 1 from 8. And we are down to 4 weeks before the final exam. So let's try and finish chapter 4 this week so we can look at chapter 5. Chapter 5 is much easier. I don't think that this is difficult, but you need to see it. We need to review it. We need to talk about it. It's not trivial.
Difficult. I just don't. I told you before I didn't understand the transformations that much. So that might be one of the reasons why I'm lost. Because obviously you deal with transformation right here.
Yes.
So,
yes.
it's
So
not that
here the
easy.
base function is log x, and when we change x into x minus 3 is a shift of 3 units to the right. Okay. So we'll go back to more graphs. So then section 4.3, properties. So now forget about the graphs. We're not going to look at the graphs right now. So this is something new, and I'm hoping that this is going to be clear. Properties of logs. There are 3 properties that no other function has. And I'm going to say plus an extra. I'll explain what the extra means in a minute. So this is unique to this particular function, to the log function. Okay, number 1, log apply to a product in any base. So let's say base 10, it doesn't matter. Log apply to a product is the product rule. And this is a sum of 2 logs, log A, log B. I want to caution you that this is not log of A times log of B. This is log applied to a product, which turns into the sum of the 2 logs. So here's an example. So if I have log of 2x, I can rewrite it as log 2 plus log x. Why? Because 2 is multiplied by x. And this is the product rule. Now, the second one, I would like you to come up with the answer. What do you think? Just common sense. Let's give it a shot. I'm not expecting you to know this. Just what you expected it to be. And of course, this will be the quotient rule. What do you think? When we had the product, we had the sum of the logs. When we have the ratio, what do you expected it to be?
Is it mine?
Exactly. Log A minus log B. So here's an example. Log of 2 over 3 is, what do you think? That's it. That's it. Excellent. Good. So one more property. Property number 3. Log apply to A raised to power B. Of course, this is the power rule. And this is the only function that allows us to take the power and put it in front as a factor, which means we'll multiply log A. Now, let me just show one thing. Log of A plus or minus log of B does not equal anything. You cannot simplify log of 2 plus x into anything. You can simplify or apply a property if it's a product. You can apply or log apply to a product, log apply to a ratio, or log apply to a power. Log apply to a sum or difference does not exist in the sense that I cannot simplify it. It exists, but I can't simplify it. So if you ask me simplify log of x plus 3, I'll say sorry. That's it. That's all I can do. There is no property that allows me to rewrite this in any way. Okay, now that little piece of extra. Let's talk about that. It's called change of base formula. Before I even talk about it, I'm going to ask you a question. Log base 2 of 8. How much is this?
It's 3.
Exactly. This is equivalent. I have no clue. The answer is no clue. But I can change it into an exponential equation. The base raised to blah, blah, blah equals 8. The base raised to whatever equals 8. And of course, there is only one answer. 3. Only 2 raised to the third power is 8. Awesome. However, if you ask me now, find log base 7 of 2, I will never be able to come up with the answer. But I can say that 7 raised to whatever equals 2. Well, of course it has to be a fraction. Of course it has to be a small number, right? So I can get 2. But what is it? I don't know. Can I find it? Yes. Using the change of base formula. So log base 7 of 2 can be determined in 2 different ways. Before we do that, I'm going to ask, do you think that I could find here only one number, or maybe 2 different numbers, or maybe 3 different numbers, or more?
Maybe 2.
It's only one. It's a one-to-one function. There is no discussion. There is only one number that I raised 7 to get 2. I cannot find 2 numbers that I raised 7 to get 2. Just one. Function is one-to-one. So here are the 2 ways. Either log of the number over log of the base, or natural log of the number over natural log of the previous base. These 2 ratios are not, careful, these 2 ratios are not this. This is log applied to a fraction. This one is a fraction of 2 logs. Not to be confused. So now I will plug in the calculator, because I can't do this by hand. So I have log of 2 divided by log of 7. And I have natural log. It doesn't matter, just don't mix and match. Log of 2, natural log of 2 over natural log 7. Of course, I can only get one number. But how do I know that this number is correct? How do I check? I raise, one more time. Exactly. I raise 7 to whatever number I got, and if the answer is, so 7 raised to the previous answer, this is what you should write. Not truncate the number, because you will get an approximation. You will get either under 2 or above 2. But if you write the previous, you use the previous answer, you will get 2. And would you agree that the answer is 0.36 approximately? Would you agree? Good. So in my notes, I would write that this is approximately 0.36. And I checked that 7 to raised to approximately 0.36 is approximately 2. It's not going to be 2. But I used in the graphing calculator, I used the previous answer.
How did you write it?
The second answer, the minus symbol right here is the previous answer. So second and previous answer. No, but I have to write 7 first. So 7 caret power, second and the previous answer. As long as that's the previous answer, and it is, and you get 2. But now if you have a different calculation, you added 2 plus 3 in here, and you try to put the previous answer, it's not going to go to that one. So you have to make it, you have to calculate it right away. You understand what I'm saying?
No.
The
But
previous
I'm
answer.
sure we'll have
So if I have two answers, the previous answer is the last one.
Okay.
It's not this one.
Okay.
So if I have this calculation with 0.36 and another one with 5, and I want the previous answer, we'll calculate with 5, not with the previous answer.
Okay.
So that's why I was saying be careful. You have to check right after you get the answer.
Okay.
Don't perform other operations with a calculator before you check. Well, you can always go back and do it again, but you understand what I'm saying. Okay, so in this section, and you will see why in the next one, we're only going to talk about condensing or expanding. It's not the same. Log expressions. Condensing, and I need to probably get rid of this. Condensing or expanding log expressions.
Is this property a log still or no?
Yes, this is why we study the properties for this. Yes. Let's start with expanding. Let's expand. We're expanding log expressions. Page 501. I'll choose the first one and then you choose the next. I'm going to choose 28 on 501. Log, base b they say, x cubed y divided by z squared.
X to the third.
X to the third, yes, sorry, my handwriting. X to the third times y over z squared. They're asking us to expand into very simple logs. Have we done this before? Yes, of course, right here. When we said log of 2 times x is the sum of logs. Another one is right here. Log of 2 over 3 is log of 2 minus log of 3. Okay, so I will start with the ratio. Quotient rule says log x cubed y minus log z squared. Now we understand that these properties go back and forth. So from here this way and then back. If I have this, I can write this. If I have this, I can write this. So it goes back and forth. If I have a difference of logs, I know it comes from log of applied to a ratio. If I have a sum of logs, I know it comes from log applied to a product. So from left to right and from right to left. You'll see how it works in just one blink. Okay, so I'm done with the ratio. There are no more ratios. But now I see a product. How do I change log applied to a product? Into log of x cubed plus log of y minus log z squared. Log of the product is the sum of logs. So I'm done with quotient, I'm done with ratio. With ratio, I'm done with the product, and now the last step is the power. This is completely simplified. No one can simplify this piece anymore. But this can be simplified because I have one property that I have not used yet. Yes, 3 log x plus log y minus 2 log z. In the first example, it may look complicated. You'll see in a moment when we look at the second and the third. So what did we accomplish? We simplified by expanding. We had log of a complicated expression, and now I have a sum or a difference of simple logs. Let me draw your attention to one thing. How many factors we have in the denominator? 1. It's the only one with minus in front because it's coming from the denominator. How many factors we have at the top? 2. They have to have plus in front because they come from the top. So keep that idea in mind, please. Okay, so please choose. Anything you'd like to see? Yes, please.
Well, I'm not for that problem. You said if it's a numerator, it has to be addition, like an addition sign, and if it's the denominator, then...
No. I said that if a factor is coming from the top of a fraction inside the log, it has to have positive in front. If it's coming from the denominator of a fraction inside a log, it will have a minus in front. It's coming from this rule. 2/3, the log of 2, because it's coming from the top, will have plus. A log of 3, because it's 3 it's coming from the denominator, will have minus in front. Very good question. Is this clear? Yes? Perfect. You're going to see this, and I just want you to make a note of it, and you'll see it again. So we can choose anything you'd like from 1 through 40. You said 5?
I don't have the book in front of me, I just picked it.
Okay. Let's do 5. So, in 5, log of 1,000 x. I don't see a base for log. What is the base?
1.
There is no base of 1. Remember, the base from the exponential can be greater than 1 or between 0 and 1. So the base cannot be 1, cannot be 0, cannot be negative. So if you remember, let's do this again. Maybe I forgot to mention it. Maybe I have to mention it. Okay, so let's take a look at the graphing calculator. We see this key, 10 to the x, and log. Why do they use the same keys? Because they are inverses of each other. 10 to the x and log have the same base, 10. These two keys are the same, they're together, right? One is activated with a second, and the other one is straightforward, right? So why is it ln together with e to the x? Because they are inverses of each other. What is the base of ln? 8. Exactly. Awesome. Well done. So in this example,
10.
exactly. We don't write it, but we know it's there. Perfect. So then, the only thing I can do here is say log of 1,000 plus log x. Why? Because I have a product inside log, which is 1,000 times x. But this can be simplified. This is done, but this can be simplified. Again, what is the base? Imagine what we've done so far. 10 raised to which power is 1,000?
10 raised to.
Right? 10 raised to the third power. Plus. 3 plus. So let's do that together one more time. So I have log of 1,000 is unknown. This is equivalent to 10 raised to which power is 1,000? 10 raised to which power is 1,000? We start with the base and we go counterclockwise. And the answer must be 3. Do we agree with 3? Everyone? Yes?
Yes.
Okay. Please choose anything else to expand.
Can we do
Yes, any.
You said 1
1 through 40. Yes, for expanding. Yes.
Let's do 26.
Let's do 26. 26. Excellent. So we have log base 8 of 64 divided by the square root of x plus 1. Perfect. How many of these quantities will have negative in front?
Yeah. What's your x? Okay.
So how many factors we see at the top?
Is 1?
Exactly. How many factors we see in the denominator?
2?
1. It's a factor.
Okay.
We talk about product. Yes. So which of these two will definitely have minus in front of its log?
The bottom.
Exactly. One of them. And the top one will be positive. Excellent. So can anyone expand this for us? Log base 8 of 64 minus
Right.
log base 8 of,
Okay.
it's a over b.
So we keep the log in the base of 8.
Oh, yes.
Both of them.
Yes, because if I want to go back, what base will I get? It has to be
Okay.
the same base. Of course, very good remark. I should have mentioned that. Of course, once I have log base 8, the same base applies to everything I write. Well done. But now the question is here. 8 raised to which power is 64?
2.
Indeed. So that part is 2. What power is the square root? What power is the square root?
Plus or minus?
1/2. So minus 1/2 log base 8 of x plus 1. And this is it. We can't do anything else anymore. You understand that there is no property for log applied to a sum. You cannot further simplify that. Is that clear?
I'm kind of lost how we got from the second line to the third line.
Yes, because x plus 1 to 1/2, log applied to log applied to x plus 1 to 1/2, 1/2 goes in front.
Can I go on the calculator or no?
No.
Where'd you get
You
one
said
out?
no.
The square root of x is x to 1/2. So the square root of x plus 1 is x plus 1 to 1/2. Is this clear?
Why would it be actually, because I thought one of the rules we learned before were that second.
So log base 8 of the square root of x plus 1, can it be rewritten like this?
It can be.
Yeah,
Right?
I understand that.
Good. So this is 1/2 log base 8 of x plus 1. I just wanted to clarify that. Yes, let's go back to maybe you have other questions.
Yeah, because I understand, what I don't understand is why it's, wouldn't it be 2 log 64?
So the power is
So
the 2,
so
right?
we are not talking about this. We're talking about this. Is that what we're talking about?
No, I get the first one that 8 raised to 2 equals 64. That's why you get rid of the 64 and bring down the 2. And then the x plus 1
We
thing
rewrote
equals
we
1/2.
rewrote this like this. Do we understand that? You have to remember the square root of x plus 1 is x plus 1 to 1/2.
So it's kind of like you can.
And then you can bring the power in front.
What if it's x plus 2?
Very good.
What is that?
The square root of x plus 2 is x plus 2 to 1/2. The
it's
square
always
root
one?
is power 1/2. The
Okay.
square root is power 1/2.
It's always 1/2.
Always.
Okay.
So, but there was some other question. Was the 2 the question then, Ella?
I'm not sure, if we do another example, I'll probably sort it out.
But is this clear from here? This piece.
Sure, yeah.
But so then this is the question. Okay, let's do that. So log base 8 of 64 is unknown, but this is equivalent to 8 raised to whatever equals 64, and the whatever must be 2.
So you put 2.
Because 2 is this. So that's why I replaced the whole thing by 2. Exactly how we replaced the whole thing here by 3.
Yeah, I didn't really know what the actual answer was for that one, to be honest.
Which one?
That
This one?
3 plus log x.
So
Oh,
this was replaced by 3, and I copy the plus, and I copy log x. So this was replaced by 3. So then the answer is 3 plus log x. Now here, the answer is 2 minus 1/2 log x plus 1. But yes, of course, we're going to look at other problems. So please choose anything else.
37. Oh wait, no. You said. Oh yeah, you did say 340, right?
Yes,
Okay, so yeah, 37.
37.
30. Oh, I'm sorry.
Can we do 38 so you can do 37 and check the answer in the back?
Sure.
Okay, let's do 38. Natural log, the top, x to the 4th, the square root of x squared plus 3 over x plus 3 to the 5th. Let's count how many factors we see. How many factors we see at the top?
2,
Perfect. How many factors we see in the denominator?
1.
How many at the end of the day will have minus in front?
No. Whoa, 1.
Exactly, the one coming from the denominator. Excellent. So can anyone dictate?
What is it supposed to say?
Yes. Can anyone dictate the next step?
Pull up. Well, I'm not familiar. I can't remember what the natural
Base E.
E.
We just write it instead of log with base E, we write ln by convention. Yeah.
So would it be natural log of x to the fourth square root x to the
Plus
3 and
natural log the square of x squared plus 3 minus natural log of x plus 3 to the 5th.
Okay.
Oh, I see.
Now you can say, I don't want to do 2 steps in one. Fine. You don't have to. That's why I'm trying to cut back on writing a little bit if we can. And that's why I asked how many factors we have at the top, 2, so they will have plus in front. How many factors we have in the denominator? 1, so only one will have negative.
Okay, can you show it with more steps, or would it be less?
So I will write natural log of the product of the top minus natural log of the denominator. But then I applied the product already and I wrote the sum. Okay, let me write it. So natural log of x to the 4th, the square root of x squared plus 3 over x plus 3 to the 5th. We have to write natural log of x to the 4th times the square root of x squared plus 3 minus natural log of x plus 3 to the 5th. Correct? And then this one changes into x to the 4th plus natural log the square root of x squared plus 3 minus natural log of x plus 3 to the 5th. And that's what I wrote.
And it's because of 2 terms at the top.
Factors.
So two
Exactly.
factors,
Right.
2
So if we understand that concept, then we will not have to write that much. But it's not wrong. Nothing wrong to write. So that's why from the beginning I said, how many factors are at the top? You said perfectly 2, so those will have plus in front. How many factors are in the denominator? You said 1, so that would have a negative in front.
Oh, so you can, and if it was 2 factors at the bottom, then it would be 2
Minus,
negatives?
minus.
Okay.
Yes. So if you want to change this into, let's say, x plus 1, then I will have minus this minus natural log of x plus 1.
Let me break that down.
No, take your time. I mean, we don't have to jump over steps. I just wanted to show you that if you understand the concept, whatever number of factors we have at the top of a fraction inside a log, then all those factors will have positives in front of their log. If whatever number we have in the denominator, all of them will be negative, will have negative in front of their log. And that will save some time. And then, especially when you have to distribute the negative sign in the denominator, so that's why I'm saying this is better. Okay, we're not done.
Not with this one?
No. Remember, there are 3 rules. As long as we have quotient, product, or power, we're not done.
Oh, so you have to go through all of these if it's there.
Yes. Yes, but when you expand, you have to start with a quotient, if there is one. Then you continue with the product, and the end, the power. This is always the sequence. Okay, so please simplify the first one. Fullest.
4.
Excellent.
Natural x.
Next one.
Natural. Well, would it be the ln thing?
I know the power. What is the
Well,
power?
1/2, right?
Exactly.
Oh, 1/2 in the front.
And the last one?
5.
That's it.
Okay.
Excellent. Do we need more, or we can look at the other way, which is condensing?
Condensing sign.
It's up to you. Do we need another?
Yeah, let's do one.
Very good. So I'm going to choose, if you allow me to, 36. Log base 2 of the 5th root of xy to the 4th over 16. So I spoke too soon. In the case in which there is a power, then I have to deal with the power first, and then the quotient, and then the product. And then the power again.
So power, if it's like that, power
If there is a
first,
power first, and then quotient, product, and power again.
and quotient is the
Ratio.
Ratio.
Right. Okay, what is the first step? I need the power out first.
1/5.
Indeed. Log base 2 of x y to the 4th over 16. Excellent.
Okay.
Now we keep 1/5 outside. Let it wait for now. Let's identify how many factors we have at the top.
Is this 2?
2. So how many will have positive in front?
Both.
Perfect. How many factors we have in the denominator? How many will have negative in front? Excellent. So then log base 2 of
X
plus
Y. No. Yeah, X plus Y.
plus log
Log.
base 2 of y to the 4th,
Oh, because the Y.
because we
goes
have
together.
3 factors.
Right.
And then, excellent, log base 2 of 16. Of course it's not done, because I have to simplify each log, and then I have to distribute 1/5 to all of them, all terms inside. Ready? I'll wait. All you have to do is just tell me to wait, and I will.
Could you just hold for a second?
I'll wait as long as you want, but not more than a minute.
No, not more than a minute.
Yeah, good.
Trying to answer the question.
I know. So then, obviously, 1/5 log base 2 of x plus. But now, I need to bring the 4 down and multiply by 1/5. So what will this one have in front? Yeah, I have to distribute 1/5 to all 3.
Would it be 4 over?
Exactly.
5, okay.
Exactly. Now let's discuss this. Is there a way of simplifying log base 2 of 16?
If something,
2
yeah.
raised to blah, blah, blah equals 16.
I mean,
2 raised to
3.
exactly 4.
4.
So this whole thing is 4,
Right.
but I have to multiply by 1/5. And that's the end of it.
So 1/5 stays outside, but it's.
But
gonna
at
be
the end, I will,
multiplied.
yes, because I want to remove brackets, parentheses, whatever. So this will go, and I will have to distribute it to all terms. I distribute it to the first.
Okay.
I distribute it to the second. That's why I have 4/5. And this is 4, but I have to distribute 1/5, and that's how I get the negative 4/5.
And it's 1/5 because that 5. What do you call that again? How the 5?
Power
is
rule.
outside?
Power rule.
Right. So because it's right there and it's with everything, it has to go outside and multiply later.
Exactly. Because this is the power on everything. So that's why it gets distributed to everything. And this is final. We don't have to look at so sophisticated. You're not going to have something too complicated. But as long as we understand it or not. We understand these 3 properties. Is that a yes?
I have a question. If you do something, so let's say with the last one that we just did, right?
Yes?
If we did this product first, right? So AB equals log A plus B.
Yes.
If we did that first, I mean, does it really matter as long as you don't do that? As long as you didn't multiply like the 1/5 times everything first, it really doesn't matter like what order you.
That's why I decomposed it into 3 parts. So you don't have to do it in 2 steps. So if you see that this has 3 factors, and one of them is in the denominator, which will have minus in front, and the other 2 are at the top, and they will have plus in front. Once you decompose it into 3 pieces, then you don't really have to think in terms of, oh, I'm applying the quotient rule first, and now I'm applying the product rule next, and now I'm blah blah blah.
You just gotta know what to do with which
Yes,
one.
based on where they come from.
Okay.
So let's do the condensing, and then we can come back and do more problems. How is that? Okay, so now we're going backwards. Okay, let's start with a simple situation, like for example 48 on page 501, and this is log of 3x plus 7 minus log x. There are no numbers in front. This is only a difference of 2 logs. So there is only one operation here that I need to perform, or one step, or one property. Where does this come from?
Quotient.
Yes, log applied to a quotient or a ratio. What is at the top? Right, the one with the positive in front. What is going to the denominator?
The log. No.
Sure.
Negative x.
But that's what I said. If it's coming from the denominator, exactly. So do not get confused on the signs. If the factor is in the denominator, its log will end up having a negative in front. The number, the quantity is not negative. But the log will have minus in front. Okay, that was a warm-up. So let's take a look at 62. 4 natural log x plus 7 natural log y minus 3 natural log z. This is not cleaned up, but you already know that what we will end up having, 2 quantities will be where, and 1 quantity will come from where?
2 at the top of the divider.
Right. But we're not ready to condense it yet. Why? Because of the numbers in front. We need to take care of the numbers in front. Where do they come from?
It's the power.
Exactly. X to the 4th plus.
Y to the 7
Yes, natural log of y to the 7th.
minus
Natural log z to the 3rd. Okay. Cherise found her love of her life.
Yeah, put like most of these on the test.
See? And what did she say 5 minutes ago? She said, I don't get anything. It was cute. Okay. And we know she was exaggerating, to say the least.
She's like, cute, I'm about to cry.
Right.
Yeah. Okay, I'm ready for the final answer, please.
So,
Natural log.
log of x4 times y to the 7 over z.
That's it. So please choose now anything you want from 41 through 70, and then we'll continue with equations. Exponential and log.
I have one
Yes.
question.
Yes.
All right, so
Yes.
the log a plus b, which is not the, okay, wait a minute. I don't know, what did you say this one was called? Log and then
Of the product.
Okay.
Log applied to a product is the product rule. Log applied to a product is the sum of logs.
Oh, so that's the product.
Exactly. So log applied to this is basically the sum of these two.
Okay. Okay.
And then when you have the minus, it's because the z to the 3rd is in the denominator. Is that okay?
Okay.
I think we need another. At least 1 or 2. So please choose. 41 through 70. However, as I mentioned all the time, if you don't review this between now and Wednesday, it will go away.
We have a test on Wednesday?
Yes, just for Cherise.
Oh, alright.
No one needs to prepare anything. She's the only one having a test on Wednesday. I'm hoping that we're finished up that homework, right? Okay. Good. So please choose, or I will.
Which numbers?
41 through 70. Anything you want.
41 through 7.
I would like to do 70 or 68.
Do 6.
Yes. Which one?
Can we do both?
Yes. So let's continue with 68. This is a little bit taking it to extreme. But you will, but you will be able, but you will be able to get it.
It's going backwards, right?
So we have to start inside the brackets.
Okay.
What do we do first inside the brackets? And the answer is
Find how many.
the number in front of the first log. This is cleaned up, this is cleaned up, but this is not.
So x.
So
plus
1/3 natural log of x plus 6 to which power?
six.
Excellent. Now I'm going to ask you, after you copy it, I'm going to ask you how many quantities will go to the denominator, and how many quantities will come or go to the numerator. One will go to the
Numerator.
excellent. And how many will go to the denominator?
2.
Very good. So please tell me, how will you write this?
What? Oh, that. So x plus 6 to the 5th. Then what is it, natural? So x, because natural is already
Do not
regular.
write natural log again, right?
X plus. Oh no.
It has to be a product. We don't have anything for plus.
Okay. It is multiple.
So then x squared minus 25.
And what, I need to eliminate this. Where does this come from?
Multiple.
It comes from thingy at the top.
The power.
Yeah.
Natural log of the cube root of x plus 6 to the 5th, x squared minus 25. As I said, this is taking it a little bit to extreme.